How to decrease Java classes dependencies. Welcome Java Challenger. By learning the principles of this video, you're going to be able to create robust and easy to test code. It will also help you to gain visibility in your company. I am Rafael Del Nero, a Java champion, and today I will show you the dependency injection solid principle. Okay, so let's now explore the fundamentals of dependency injection. So the first concept to keep in mind is that high-level modules should not depend on low-level modules. What does that mean? It means that service classes shouldn't depend on low-level classes, such as a class that does operations with the database, for example, would be a low-level class or a low-level module class. And classes should depend on abstractions instead of the direct implementation of the other class. It doesn't mean that we need to use interfaces for everything, but it means that we should prefer using abstractions instead of using the class directly. And the other important concept is that abstractions should not depend on details, and details should depend on abstractions. So for example, the service class should have a dependency of a repository, but a repository should not have a dependency of service. So our goal when we are implementing our code is to organize it as much as possible and to make it as restrictive as possible. Okay, so let's now see the types of dependency injections we have. So let's start with the constructor dependency injection. So this is by far the most popular use of dependency injection, and it's also the preferable way to use dependency injection. Why? Because we have many benefits on using constructor dependency injection. We have immutability because we can only pass the dependency when we are creating the class. This means that we can't change the dependency in runtime. It's also simpler because we pass the dependency once and that's it. And we have the benefit of encapsulation because we don't need to expose to be accessed directly. And the other great benefit is that we can easily test our classes because we are passing the dependency via constructor, and that gives us control to do the tests we want. We also have the setter injection. Like I said, it's preferable to use constructor injection, but in some exceptional cases, using setter injection is useful. So let's see some pros of using the setter injection. So setter injection is useful for optional dependencies, which means that if you don't want to pass a dependency all the time that you create the class, then it's a good idea to use a setter injection. It also gives you flexibility because you can change the dependency in runtime. So if you need to change the dependency according to a conditional you have, then you can change it. You can use a setter injection. Another common case scenario is to use setter injection to test specific dependencies, because sometimes it's not enough to pass the dependency via constructor. So in some exceptional cases, it's useful to use the setter injection for some specific unit tests. And readability as well, because let's suppose that for some reason you need to have lots of dependencies, and if you put all of them in the constructor, it might get the code confusing. So you have the option of also having some dependencies via setter, so you can make the code a little bit more readable. So the cons of using setter injection is that it violates immutability, which means that you can change the dependency whenever you want. You can invoke the setter whenever you want, and you can change the dependency whenever you want. It also increases the risk of null pointer exception because we might simply forget to invoke the setter injection. And then what will happen is that if we try to use that class that is null, we're going to have the null pointer exception. Unless we handle that, unless we are doing a validation before using this class. And tests are more complex as well because you have to set each dependency via setter. And again, you might forget to set those dependencies. We also have this less common way to do injection, which is the interface injection. And I wouldn't worry too much about this one because in my 15 years of experience as a Java engineer, I never seen this interface injection being applied anywhere. But it's good to know because we don't know when we might need it. So with interface injection, the pros are that we have explicit contract, so we know what's going on there. And we have better decoupling as well, because to do this interface injection, we're gonna need an intermediate interface to specifically inject the class. And the cons are that it's intrusive. To do the injection, we need an extra interface. It's more complex, so we need to create an extra interface, and this interface has to be focused on only injecting the class. Testing overhead, we have more classes to manage, and it's less common, it's less intuitive. The code is not clear, and a benefit I can see of using this pattern is that we can decouple even more the dependency injection, which means that if we want to change frameworks for dependency injection, then it's easier. Then this could be a good case scenario to use interface injection. Otherwise, I would avoid it because it makes the code more complicated, more difficult to maintain. So what are the benefits of using dependency injection? So the first one is decoupling. Why? Because then the classes, they don't depend directly in the instance. And that makes the code more modular because then we use the powerful concept of inversion of control, which means that the class that is invoking the other class has the control of the instance. So if we have one method that receives only an interface, then the client class can pass any implementation to the other class. So this is the concept of inversion of control. Testability. So if we have a constructor injection, setter injection, or whatever, dependency injection, we can easily pass this dependency to be tested via unit tests. So that makes our code more testable. Maintainability, because that gives us more flexibility and it enables us to pass any implementation we want to classes. And that gives us flexibility as well because, like I said before, we can declare a parameter as an interface in one class, and then we can pass the implementations to this other class. So that gives us flexibility to add more features or fix bugs more easily. So when should we use a constructor or setter injection? So like I said before, it's preferable to use constructor injection, but let's see when the situation is more appropriate. So when dependencies are mandatory, it's recommended to use constructor injection. For immutability, so that restricts your code, is also more robust against bugs. For thread safety, which means that you would avoid race condition. And it will also simplify tests because you pass the dependency only once and there's no complication there. And the setter injection you would use when dependencies are optional. So when you don't need necessarily an implementation for a dependency, then use the setter injection. Or if you need to change the dependency during runtime for some reason, it's preferable to use the setter injection as well. And when you need more flexibility, so for example, when you have a specific test case scenario, then it's suitable to use the setter injection. And that's pretty much it for the fundamentals. Now let's go to the fun part. Let's go to the code. Okay, so let's see first an example not using the dependency injection principle. So the first example is this data service. And as you can see, this is a high-level module class. And this class is using the SQL database class. So we are not using the dependency injection principle here. Instead, we are directly instantiating this class, which is not good. It makes this class difficult to test and difficult to maintain as well. And this is the implementation of the SQL database class. This is a low-level module class. And as you can see, we have some code here. So imagine we have a complicated logic here. So this is just a code example, okay? So this is also bad to unit test because notice here that we can't pass this database dependency anywhere here. It's a private variable. So this means that we have to break encapsulation in order to pass this database and test this code. This is not good at all. The only way to test that would be to use reflection, transform this attribute to public in some way, break encapsulation, pass the dependency here, and then we would be able to test that. But it's a lot of steps, and this only makes code maintenance more difficult, right? And here is just the main code to execute our data service. So let's see what's the output. There's not much happening here. We are just invoking this method. So now let's see an example using the constructor dependency injection principle. So we have now the database interface, so which is the abstraction. And now we have the file database that is implementing the database class. And here we have some code. And this SQL database is also implementing database. Now in the data service, we are not relying directly in the implementation anymore. Now we are relying on the interface, which means that we can pass any interface we want, and that gives us flexibility to pass either file database or SQL database or any other database we want to include here. So that gives us a lot of power and flexibility to evolve our code. So now notice that it's very easy to pass the database here through unit tests. We don't need to break encapsulation anymore. We just need to pass the database we want in the constructor. So that makes the code much easier to test and maintain. And here we invoke the save data method either from file database or SQL database. That gives us a lot of power in our code. So here is the implementation. So notice here that we can either pass the SQL database or the file database. And notice that we are using a very important concept here. And this concept is called inversion of control. So notice here that this main class has the control to pass any implementation it wants, right? So if we want to pass SQL database, we can do that here. Or if you want to go back to file database, we can do that from here. So this class, data service, knows nothing about SQL database or file database. So this is the meaning of decoupling class, because this class knows the minimum to do its logic here. And that's what we want to achieve in our code design. So let's now execute this code. Yeah, so you can see here that we will have either the data saved to file message, or if we pass SQL database, now let's see the output, data saved to SQL database. So now let's see an example using the dependency injection via constructor for a notification service. So let's first analyze the user notifier class. And in this class, notice that we are using the constructor dependency injection. So we are relying on an interface instead of relying on an implementation. It doesn't mean that we need to exactly rely always in an interface. We could use a superclass here as well, but in most cases, we're going to use an interface, right? So let's see this notification service here. So it's very simple. We only receive a recipient and a message, and we have two classes implementing this notification service. So we have the email notification service, and we're doing some logic here specifically for this class. And we also have the SMS notification service also implementing the notification service. And we are sending an SMS message. Like I said before, this is very good because we can easily pass the dependency here. We can easily pass the implementation, and we can easily test this class as well. We can test the send notification method with our implementation here. So now let's see the main class. So again, we are using the inversion of control concept again. Why? That's because the user notifier doesn't have control in the implementation of the notification service. Instead, the main class has the control to pass any implementation it wants. The other benefit of decoupling our code at that level is that, for example, if I want to add a new notification service, for example, direct message notification service, we can do that very easily. So let's do that. So we're going to implement notification service. So as you can see, it's very easy to add new features. Here we are passing direct message. So again, here we are using polymorphism. So notice that we are declaring our variable with the interface, not with the implementation. So this is a very important concept to remember, right? So here we are instantiating a direct message notification. So which means that we can also pass our service here. As you can see, the more we decouple our code, the easier it is to maintain. So notice again that the user notifier class doesn't know anything about direct message notification service or SMS notification service or the email notification service. So this is the meaning of decoupling our classes, is to make our classes know the less as possible about the other classes. Because then, if we have that level of decoupling, as you could see here, we could very easily add the direct message notification service. So this gives us a lot of power to maintain and evolve our code. So let's now execute this code to see what happens. So as you could see, by passing the implementation we want here, the correspondent method will be invoked. So first, it's the method for the email notification service. The second one is for SMS, and the third one is for direct message. And to reinforce, remember that we are also using the inversion of control concept, which means that the main class has the control, has the power of choosing whatever implementation it wants to pass to user notifier. User notifier only knows the notification service interface. So now let's see an example of using the setter dependency injection. So we have the account manager class, and notice that we are passing the instance of this class via setter. And like I said before, using the setter injection is good in exceptional cases, but we must give preference to use constructor dependency injection, because as you can see here, we could more easily have a null pointer exception. So we have to handle the dependency because there's nothing here that will guarantee us to invoke this setter. So we might forget to invoke this setter method, and then we might have an issue because this account service might be null. Here we are handling that, but this is extra complexity. So a setter is only recommended in exceptional cases. When you need to do a very specific test, then it's okay to use a setter injection. Ideally, we should avoid it as much as possible. So here, as you can see, we have the account service. The account service is an interface that has two implementations. So imagine we have some code here to manage account, admin account service, and we also have the user account service. Imagine we have some complicated code here as well. And here, notice that we are instantiating the user account service and the admin account service. We are again using polymorphism here. And then we instantiate the account manager. And notice here that we have to remember to pass the account service here, right? Let's see here what happens if we don't remember to pass. So we are handling this code, right? So in this case, we have this log message, account service not set. But if we go here, count service, and if we try to use that directly, then we will have a null pointer exception. This wouldn't happen with the constructor dependency injection, because with the constructor, you can't forget to pass the dependency. So that's the thing. A setter dependency injection is good when you need to change the dependency in runtime. When you need more flexibility to manipulate the dependency, then yes, the setter dependency injection is good. But I would avoid it as much as possible, because by having a setter, dependency injection via setter, it gives us more chances to create bugs in our applications. So prioritize the use of constructor dependency injection instead. So now let's see how the interface dependency injection works. As I said before, this is not very used and it's more complicated. And other than that, in 15 years of experience as a Java software engineer, I never used this principle. So don't worry too much about this one. It's just good to know it exists, because we never know if we might need it. So this is the abstraction class, and this is the printer service. The only class that is implementing this printer service is console printer service. So imagine we have some logic here to print the message. And the other thing to notice about the interface dependency injection concept is that we need an intermediate interface that is responsible to inject our dependency. So on this service injector, we will inject whatever the console we want in this printable client. So let's see here how that works. So we have this inject method here, and in this class, we have the console printer service injector. So this class is responsible for solely inject the console printer service within the client. Like I said before, this is not straightforward. This is not intuitive. So this would be used only in very specific cases where you need to make your code not strongly dependent on frameworks that handle dependency injection. And this would be the example of printable client. So we are injecting the printer service here, and we print the message here. So here in this main class, notice that we have this printable client, and we are also instantiating the injector. So we are passing this console printer service injector, which is responsible to inject the console printer service. And in the injector, we are passing the client. And like we saw here, this class will inject the printer service in the client. That's the only purpose of this injector class. And then we are able to invoke the print message method because we pass this printable client instance to this inject method. And then we pass the implementation of this console printer service into the set printer service. So let's execute this class to see the output. Yeah, so as you can see, it works fine. But like I said, lots of layers, it's complicated. We should avoid this way to use dependency injection as much as possible, unless it's required to decouple our dependency injections into a separate interface. Then it makes sense. But otherwise, I would avoid it as much as possible. Okay, so now let's explore how to use dependency injection with frameworks. So I'm gonna use Spring as an example because it's the most used framework for Java developers, but the concept is pretty much the same if you use any other framework, right? So if you use Jakarta or Google Juice or whatever framework you can think of, it's gonna be the same. It's gonna be pretty much the same. So let's see here then. So notice here that we have the account service interface and we have the implementation of this account service, which is the user account service. And imagine we have complicated code here, and then we have the account manager code. And the other thing to notice is that we have this service annotation. So when we put this annotation here. So basically we tell Spring that we want Spring to manage the instance of this service so that we don't need to worry about instantiating this service manually. And then we have this component, which is the account manager. And this account manager is using the constructor dependency injection. And this auto-wired annotation basically means that we are telling Spring, hey Spring, we want the dependency you are managing now. Then Spring will be able to provide the instantiation, the implementation of this interface as we want. And this component class, we are also saying that, hey Spring, we want you to manage this account manager instance in your container. Because then we can say, hey Spring, give me the instance, please. So this is the most common way we use dependency injection with Java. So we wouldn't be doing that manually. We would be using a framework that is handling those dependencies for us. And yeah, so it's quite similar from the previous code. And here we have the implementation. Here we instantiate the context of Spring. Now, the other important thing about Spring is that we need to tell Spring, hey Spring, please scan this package. Scan this Spring package, because in this package there are dependencies I want you to manage. So basically that's what we are telling Spring here. And then Spring is able to manage those dependencies, right? Because then we can use the context and we can say, hey Spring, it's time to give me the account manager class. And then we get back the account manager and we can invoke the manage method. So let's run this class. Let's see what happens. Yeah, so as you could see, we have here the output we were expecting. And we have here managing user account with ID user 123, which is what we passed here. So remember that dependency injection is extremely important because it makes our code more flexible. We can more easily maintain the code. We can more easily test our code as well. Prefer constructor dependency injection rather than setter dependency injection or interface dependency injection. And notice that in a real Java project, you're going to be using a framework to handle dependency injection. So, and the best practice to use dependency injection is to use it via constructor. And by decoupling our code as much as possible, it's easier to fix bugs and also add new features. Remember that. And I also have a special invitation for you because on the 4th of July, I will run a live webinar to help you stand out as a Java developer and get the job you want while being well paid for that. And this webinar is totally free and you can get registered in the link below. So I'm gonna leave the link on the description of this video and I'll be waiting for you there. I'm really looking forward to help you overcome your career challenges. And the good thing about being the webinar is that you can ask me questions directly about your career and how to go to the next level, okay? So thank you so much for watching this video and I'll see you next time.